Ever feel like those airport terminals are their own little world?
Mm-hmm.
Well, get ready to go from passenger to pro because today's deep dive is all about what makes airports tick.
Okay.
We've got your stack of flight training manuals and study guides right here.
Yeah.
So buckle up.
And you've touched on something fascinating right off the bat.
Okay.
Most people only see the frantic pace of catching a flight.
All right.
But these sources you've provided, like especially this PHAK Chapter 14 document,
Okay.
it's like a gold mine of information on airport layouts, communication procedures,
Yeah.
and even the psychology of pilots.
Okay, so let's unpack this.
Okay,
First off, not all airports are created equal, right?
you got it.
It's not just about those mega hubs you see in the movies.
Exactly.
Okay.
Your PHAK source actually breaks it down into 5 main categories,
Okay.
ranging from those bustling commercial airports
Mhm.
all the way to smaller general aviation fields.
Okay.
You've got your cargo airports. Think massive planes moving freight, not people.
Right.
And then there are reliever airports,
Okay.
which are designed to ease congestion at those busier hubs.
So basically a pressure valve for the airport ecosystem.
Exactly.
Yeah.
And your lecture notes highlight this.
Right.
Even within general aviation, you've got a huge range from small, privately owned airfields
Right.
to those used for flight training,
Yeah.
or even some with smaller scale scheduled service.
Okay.
It's a whole network that most people don't even realize exists.
It really highlights how much goes on beyond those big names you see on airline websites.
Right.
Now, another distinction your sources make is between towered
Yeah.
and non-towered airports.
Right.
That seems pretty fundamental, right?
It is. It's a huge difference.
Yeah. Okay.
Think about the difference between driving on a highway with traffic lights
Okay.
and navigating a quiet country road.
Mm-hmm.
A towered airport has air traffic control, or ATC,
Right.
actively directing traffic
Yeah.
to keep things safe and efficient.
So constant communication with the tower is key there.
Exactly.
Okay.
Pilots need to be in constant contact with ATC,
Right.
following their instructions for everything,
Yeah.
from taxiing
Right.
to takeoff and
Yeah.
landing.
Okay.
But at non-towered airports,
Yeah.
things are a bit more autonomous.
Like a self-governing aviation community.
In a way.
Yeah.
While two-way radio communication isn't mandatory at non-towered airports,
Okay.
it's still considered best practice.
Okay.
Pilots use a common traffic advisory frequency, or CTAF,
Right.
to announce their positions and intentions,
Okay.
which helps maintain awareness in the air.
Okay. That makes sense.
Yeah.
It's like a friendly heads-up system for everyone in that airspace.
Exactly.
Now, something I've always wondered about, are those runway numbers?
Yes.
Our sources actually break down what they signify.
Right.
And it's actually pretty clever.
Yeah, it's very clever. Yeah. It's all about magnetic north.
Okay.
Runway numbers
Mm-hmm.
are assigned based on their magnetic heading,
Okay.
rounded to the nearest tenth.
Okay.
So
Yeah.
runway 9 points,
Mm-hmm.
roughly 90 degrees east of magnetic north,
Okay.
while runway 27
Yeah.
is 270 degrees.
So a pilot landing on runway 9 is basically landing facing east, magnetically speaking.
Exactly.
Okay.
And those L or R designations you sometimes see,
Right.
those indicate parallel runways,
Right.
like 9L and 9R,
Okay.
allowing for simultaneous operations.
That makes a lot of sense for busy airports.
Exactly.
Now, can we talk about traffic patterns?
Sure.
Your sources make it sound like a carefully choreographed aerial ballet.
It's a great analogy.
Yeah.
Imagine a standardized flow of aircraft around the runway,
Okay.
kind of like cars following lanes, but in 3 dimensions.
Right.
Usually have 4 main legs:
Mm-hmm.
upwind,
Okay.
downwind,
Right.
base,
Yeah.
and final. And your first source, the one that dives into go-arounds,
Right.
highlights how a pilot might have to abort a landing
Okay.
and use that upland leg to circle back for another try.
And the other legs all have their specific roles to play in this airborne choreography.
Think of it like this.
Yeah.
The downwind leg is parallel to the runway,
Okay.
but going in the opposite direction of landing.
Okay.
The base leg
Mm-hmm.
is a 90-degree turn
Okay.
to position the aircraft for final approach.
Right.
And then the final leg brings them in for a landing.
Okay.
And those segmented circle indicators you see at some airports,
Yes.
those help pilots visualize these patterns
Okay.
and any variations.
It's like a visual guide to help them stay on track.
Exactly.
Yeah.
And even if you're not a pilot,
Right.
understanding these patterns can be useful if you're working near an airport.
Right.
Knowing the general flow of aircraft
Yeah.
helps you anticipate where they might be and adjust your operations accordingly.
It's like having a mental map of those invisible highways in the sky, knowing where the traffic is flowing.
Exactly.
Now, our sources also delve into those markings and signs you see all over an airport.
Right.
And I've always found them fascinating, like a visual language for that whole ecosystem.
They are.
Yeah.
Think of them as the airport's version of traffic signals and road signs. Providing crucial information to pilots navigating the tarmac.
Right.
Your PHEK source is a great guide to this visual language. For example, those runway holding position signs.
Yeah.
They're essentially the airport's stop signs.
Right.
Telling pilots where they absolutely cannot cross without clearance from ATC.
That red and white sign definitely stands out, hard to miss.
Right.
Yeah. And I've noticed all sorts of markings on the taxiways, too.
Exactly. You've got your taxiway centerline markings, holding position markings for taxiway intersections, and even enhanced taxiway centerline markings that warn pilots they're approaching a runway. It's all about maintaining awareness and preventing those dangerous runway incursions we'll be talking about later on.
So much information packed into those seemingly simple markings.
Right.
Yeah. And then there's airport lighting, which adds a whole other layer of complexity.
It does.
Especially for nighttime or low visibility operations.
Absolutely.
Yeah.
Your sources really shine a light on this, pun intended. You've got those airport beacons. Rotating white and green lights that help pilots identify the airport from afar, especially at night. Then there are the approach light systems, providing a visual reference as pilots transition from instrument to visual flight for landing.
I've always been curious about VSIs, or visual approach slope indicators. They're the sets of lights that tell pilots if they're on the correct glide path for landing right.
Exactly. Your PHA source actually has a great visual breakdown of this. If a pilot sees all white lights, they're too high. All red too low. And a combination of red and white means they're right on target. And there are other types of glide path systems too, each with its unique way of providing guidance.
It's like having a visual checklist in the sky.
Right.
And of course, there are all those different runway lights. From the edge lights that outline the runway to those centerline and touchdown zone lights that help pilots judge distances.
And don't forget those all-important taxiway lights.
Right.
Blue for the edges, green for the center lines.
Right.
Guiding pilots along their designated routes. It's all a meticulously designed system to enhance safety and visibility, no matter the weather conditions.
It's amazing how much goes into making sure airports can operate smoothly 24/7.
It is.
But beyond the physical aspects, our sources also delve into the human side of airport operations. That remote pilot study guide you shared is full of insights into decision-making models for pilots. Common operational pitfalls they face, even the importance of stress management in such a high-pressure environment.
It's fascinating, isn't it?
It is, yeah.
The study guide highlights the perceive, process, perform model. A continuous loop of assessment and adjustment that pilots use to make decisions. Essentially, a pilot needs to first perceive the situation, process the information by evaluating its impact on safety, and then perform the best course of action.
But as you mentioned, even experienced pilots can fall into those operational pitfalls, right?
Absolutely.
Yeah.
The study guide mentions things like get there-itis, where a pilot's desire to complete the flight might override their better judgment, or even succumbing to peer pressure. It emphasizes that stress management is crucial, because, as the source points out, high levels of stress can significantly impair decision-making.
It's a good reminder that even in a highly technical field like aviation, the human element is paramount. And speaking of human factors, our sources really hit home the importance of avoiding runway incursions, those close calls that can have serious consequences.
Runway incursions are a major concern in aviation safety, and your PHAK source really breaks down how to prevent them. It stresses clear communication with ATC, knowing the airport layout, understanding signage, and maintaining vigilance throughout taxi operations. Basically, it's like defensive driving, but for airplanes.
The source also mentions that runway confusion can be a significant factor in these incidents.
It is.
With so many taxiways and runways, it's easy to see how a pilot can make a mistake. Especially at night or in low visibility.
Exactly. Your source highlights how airport complexity, the close proximity of runway thresholds, And even the joint use of a runway as a taxiway can increase the risk of runway confusion.
Right.
It even cites an example of a regional jet that mistakenly took off on a shorter runway.
Oh, wow.
Leading to a tragic crash.
That's a stark reminder of just how important it is.
Right.
For pilots to be incredibly careful when navigating the airport surface.
Absolutely.
Yeah.
And it's not... The source also emphasizes using proper radio procedures, including the phonetic alphabet, to ensure clear communication with ATC.
Right. Alpha, Bravo, Charlie.
Exactly.
It all makes sense now why that level of precision is so crucial.
Absolutely.
Yeah.
Especially when you consider the potential for miscommunication.
Right.
And the fact that lives are literally at stake.
Right.
And in case of a radio malfunction,
yeah,
your source outlines lost communication procedures, advising pilots to remain outside controlled airspace until they can determine the flow of traffic, and then use visual signals to communicate with the tower.
It's like having a backup plan for when technology fails.
Exactly.
Which is always reassuring.
Right.
Now, our sources also mention this fascinating technology called EMAS, or Engineered Materials Arresting Systems.
Right.
It sounds like a literal safety net for overrunning aircraft.
It is. Think of it as a special kind of crushable concrete installed at the ends of some runways, designed to stop or slow down an aircraft that has gone past the end. Your PHA source details several incidents where EMAS has successfully prevented serious accidents, including one involving a Boeing 747 at JFK.
That's incredible.
Yeah.
It really highlights the lengths airports go to in order to enhance safety.
And your source points out that EMAS information is included in the chart supplements. Those detailed guides for each airport.
Right.
This means pilots have access to this information before they even land, allowing them to factor it into their decision-making if they ever face that critical overrun situation.
So it's not just a passive safety feature. It's something pilots actively consider.
Exactly.
Right.
But it's important to remember that EMAS has limitations. It might not be effective for all types of aircraft, particularly smaller ones.
Right. Now, shifting gears slightly, we should talk about those critical data sources that pilots and ground crews rely on. Chart supplements, NOTAMs, and ATIS broadcasts. These are like the essential tools for anyone working near an airport, wouldn't you say?
Absolutely.
Yeah.
Your lecture notes really emphasize their importance. Chart supplements are what used to be called the Airport Facility Directory, are like encyclopedias of airport information. They provide details on everything from communication frequencies to runway lengths, lighting systems, and even special procedures for that specific airport.
So they're essential for planning any operation, whether you're a pilot preparing for a flight
or a ground crew member coordinating logistics.
Exactly.
Right. And then you have NOTAMs, or notices to airmen, which are like real-time updates on any temporary changes or hazards that might affect airport operations.
Exactly.
Runway closures, construction, changes in navigational aids, even bird activity. It's all in there.
It is.
Your source also mentions that there are specific NOTAMs for drones as well.
That's right.
Called DROTAMs. So no matter what you're flying, checking those NOTAMs is non-negotiable.
Exactly.
Right. And finally, we have ADIS, or Automated Terminal Information Service. A continuous broadcast of local weather conditions, runway information, and other relevant details for pilots. Think of it as a local news station for the airport, constantly providing the most up-to-date information.
Exactly.
And those 80 broadcasts are coded like Information Alpha or Information Bravo.
Precisely.
This coding system helps pilots know if they have the latest information, especially when conditions are changing rapidly. It's a simple but effective way to keep everyone on the same page. And just like with those chart supplements, pilots should always check the ATES before they even contact the tower, ensuring they have the most current information for a safe approach and landing.
It's amazing how all these different elements, from the physical layout and technology to human factors and communication protocols, come together to create a safe and efficient airport environment.
It really is a testament to the complexity and precision required to keep those planes moving.
Going through these sources, it strikes me how much airport operations are a balancing act.
Yeah.
Between the technical and the human. You've got all these sophisticated systems in place.
Yeah.
But it ultimately comes down to people making the right decisions.
You hit the nail on the head. That Chapter 11 remote pilot study guide you provided really emphasizes that human element.
Okay.
Especially when it talks about those decision-making models for pilots. It's not enough to just know the procedures.
Right.
Pilots need to accurately perceive what's happening around them.
Okay.
Process that information quickly and effectively.
Right.
And then perform the appropriate action.
And that's where those operational pitfalls they list become so fascinating. Like get their itis, that feeling of being so focused on reaching your destination that you start overlooking potential problems along the way.
Right.
I can definitely relate to that in everyday life.
Yeah.
But for a pilot, I imagine that urge to just land the plane could be pretty intense.
Absolutely.
Yeah.
And that source doesn't sugarcoat the potential consequences of those pitfalls.
Right.
It even links get theiritis to things like succumbing to peer pressure.
Wow.
Which is surprisingly relatable even if you're not flying a plane. It's a good reminder that those psychological factors can affect anyone's decision-making.
Yeah.
Regardless of their skill level.
Yeah, we've talked a lot about pilots.
Right.
But what about the folks on the ground?
Yeah.
That lecture notes for airport operations document you shared?
Right.
Touches on some crucial information they need to be aware of, right?
It does.
Okay.
For example, it stresses understanding runway orientation.
Okay.
Which is essential. Even if you're just working near the runway, knowing which direction planes will be taking off and landing helps anticipate things like noise levels, potential debris, and even just being aware of where it's safe to be.
It's like having a mental map of those invisible highways in the sky.
Exactly. Knowing where the traffic is flowing.
And that source also highlights the importance of understanding wind indicators, which is crucial for anyone working on an airport.
It is.
Right.
Knowing the wind direction helps you anticipate aircraft movement patterns.
Okay.
As well as potential hazards like wind shear.
Right.
It all comes back to maintaining that constant situational awareness.
And speaking of awareness, we haven't even touched on those chart supplements and NOTAMs we discussed earlier.
Right.
Those seem like required reading for anyone working on or near an airport, whether they're flying a plane or driving a luggage car.
Absolutely.
Right.
Think of it this way.
Yeah.
Chart supplements are like having a detailed roadmap of the airport.
Okay.
While NOCAMs are like getting real-time traffic updates, construction alerts, even weather advisories. They provide that granular level of detail that can make all the difference when it comes to safety and efficiency.
So to bring this all home for our listener today, they've now got a solid understanding of how airports are categorized, how runways are laid out and marked, the secrets hidden in those airport lights, and even the human factors that can make or break safety.
It's a lot to take in.
What's the one big takeaway you hope they walk away with?
Honestly, it's that sense of interconnectedness.
Okay.
Airports are incredibly complex systems with so many moving parts.
Right.
But they rely on everyone understanding their role and following procedures, whether you're a seasoned pilot or just starting a job at the airport.
Yeah.
That shared responsibility for safety is paramount.
Yeah, I love that. It really highlights how even in this highly technical world of aviation, it's that human element. That shared understanding and commitment to safety that keeps things running smoothly.
Exactly.
Well, this has been a fascinating look behind the scenes at the world of airport operations.
It has.
Thank you for lending your expertise to this deep dive.
My pleasure.
Until next time, safe travels.